Hey folks, class WR514. This is my last GIS exercise presentation, and what I'm doing here is calculating watershed statistics, specifically precipitation from known points and how that is kind of distributed across watersheds. My study area is by Salt Lake City. These are the smaller watersheds right to the east of Great Salt Lake. And so what I'm doing in this first step is I'm dissolving these smaller watersheds into uh, their larger watersheds. And yeah, a lot of time, you can find Huck 8, Huck 10, and things like that. So you may not need to do this step. But I chose to do this step because of how precipitation gauges were distributed in the area and where the three main streamflow gauges are at the bottom of, of these watersheds. So what I did is I did the like calculate statistics tool on Arc Pro, and so this is looking at those new polygons that I made from the larger, made into the larger watersheds. And really what I'm going after here is the um, is mainly the area, and that's going to play into our calculations for the precipitation distribution later. And kind of just for fun, I hadn't used this tool, but this is like the delineate watershed, the auto tool, not the one where you choose the pour points and use flow accumulation and all that. Um, this is the auto tool in Arc, and what it does is it just assumes kind of pour points and then uses the elevation of the DEM and the flow accumulation to delineate these watersheds. And what's interesting about this is that these watersheds overlaid with the ones that I made from combining and dissolving don't quite line up the same. Pretty close, but still just a little bit different. And then the larger dots at the bases of those watersheds, those are the stream gauging stations. Okay, and all those smaller dots, so those are rain gauging stations. They grab pretty much annual precipitation. I'm sure there's a higher resolution like daily data if you really got into it, but what I'm using right now is the annual precipitation. So that's this table over here on the right. If you'll go to the far right, that's this column is annual precipitation. That's in millimeters. Salt Lake, it's somewhere around 18 inches of precipitation annually. Obviously a lot more this year, but those those millimeters, I think it's like 8 or 900 millimeters, ends up being about 18 inches of precipitation. And the map on the left is just sort of how those are distributed throughout our watersheds. So here's a really cool tool, Thessian polygons. And so what this does is it draws polygons around those precipitation gauges, and whichever point you choose, or let's say you're in that city, whichever polygon you are in, uh, is the closest rain gauging station to yourself. I've seen this done on a national park map, which is really cool. So you could see whatever city you lived in and what was your closest national park. Draws these like triangular and hexagonal um, boxes, and that's on the next page. So here is after running that tool, and you get to choose what attribute that you're drawing around, the way that it figures that out. And so what this is so like these gauges, these two that are like right next to each other, it will put them in different polygons and kind of add the area. So we're going to use that to calculate um, all the areas that we don't have data for in Tropila. All right, so that's what's going on here. This is an empirical Bayesian kriging tool. It's the first time to use this. And so what it does is it uses an algorithm, and you pick the uh, column from the attribute table that you want it to interpolate the data in between, and it fills in those spaces. All the orange The darker red, that's areas of high precipitation, where the blue and all that is areas of lower. Um, you may have seen if you've ever used Prism climate data out of University of Oregon, this is kind of how they do it too. This model does not take into account elevations. There are, I think, more advanced models that do. And so now what we want to do is to figure out how much precipitation is going on in each watershed on average. So what we're doing is we're overlaying the watershed map on the right with the one on the left to run some further analysis. Okay, so that's what's going on here. Pretty big map. It's not two separate areas. I just wanted to extend it over to show how close we are to Great Salt Lake. And then I overlaid the watersheds, polygons, on top of the interpolated data. And then I inverted the gradient. So the darker areas of the watersheds are actually areas of less precipitation. May not be intuitive. This is what I did so that I could uh, kind of create a contrast between the areas. And then here's the final analysis. So what I did is calculated average annual precipitation in each watershed based off of this interpolated model, and then what percentage of that precipitation winds up in each watershed. So kind of what's going on here up at the top of the screen, that little table, that is the average annual precipitation in millimeters for each watershed. The watersheds actually have much longer identification numbers. I just took the last three digits. And then so if we let's look at the pie chart, like over here at WS304. So 304 has the least amount of precipitation. And if you go over here and look at the map, you see 304, it's on the left side of our map, is like all in the blue area, which is not much precipitation. And so that checks out. And same thing going on with 302, most percentage. And if you look at it, not only is it a larger watershed, but most of it is yellow and darker orange. So thanks everybody. Thanks for checking it out. Have a good day and let me know if I can answer any other questions.